Hey everyone, this is the Math Nexus, and today we are going to start with exercise 3.2 of the O level and IGCSE additional mathematics. Now, this exercise is only based on the factor theorem. And so basically, the factor theorem is something we already know about, and it's basically an overcomplication of basic knowledge we already have. Okay, so I'll just start off with an example. For example, I have 36 as a number, and I say I have to divide 36 by 3. Okay, so if I divide 36 by 3, I get 12. Okay, here we go. 36 divided by 3 is 12. Now, there are three main things we do know about this. Okay, so whatever value we are dividing is going to be called the divided. I'm going to change my color for this one. So this is called the dividend. Okay, so now the value we are dividing it from is called the divisor. So this is the divisor, and the answer we get is called the quotient. Now, each of these things have their own importance. You already know this. But if we, could change their places for a bit of time, we could know that if we multiply the quotient by the divisor, we would get the dividend. Okay, it's common knowledge. By the way, I'm sorry I copied the spelling for dividend wrong. It's not supposed to be a T, it's supposed to be a D for dog. So sorry for that. So if I multiply 12 and 3, I get 36. And now the important thing is we have to know how we manipulate equations, especially in this factor theorem field, because I'll get to it. And if I were to, start off with something I already have, this is the question number 4B answer we had done in the previous lecture. So this is basically what we get. We got x cubed minus 8 divided by x minus 2 in the question, and we were supposed to find this x squared plus 2x plus 4 as our answer. So we basically divided these two, and from which we got this answer. Okay, so no big deal in this. Okay, but the thing is, you have to understand one of two things. Okay, so basically, if I say this x cubed minus 8 divided by x minus 2 would give me x squared plus 2x plus 4, I would do the same thing here. If I multiply the quotient, which is x squared plus 2x plus 4, by the divisor, which is x minus 2, I should get x squared plus 2x plus 4 divided by x minus 2. I should get x cubed minus 8. Now, the explanation I'm just giving right now is overcomplication of this method, that if I would have said I take x minus 2, it's being divided here, so it would be multiplied here. So it's just an overcomplication of this method. But why I'm telling you all of this is I'll reach to this in 1 second. Okay, so if I were to say, for example, let's say that we have, let's assume this as a function. We'd say x cubed minus 8 is the function fx, and this x squared plus 2x plus 4 is a function gx, while this x minus 2 is actually what we called as our divisor. So this is a divisor. Okay, so if I have something like fx is equals to x minus 2 multiplied by gx. So if I have something like this, how would I know that this gx is a factor, and this x minus 2 is a factor of fx and gx? So how would I know this? For example, I have this 36 divided by 3. How would I know that this 36 divided by 3 would give me a factor without any remainder? Okay, it would give me 12. I know this. For example, if this would have been like 36 divided by 7, this would not have been a whole number. Okay, this would give me the answer 36 divided by 7. And that answer comes when we have a remainder in the method. Okay, so basically, fx would only be a factor when the answer for x would be 2. And what I mean by this is if I get input the value of x minus 2 as 2, I would get 0 here and gx, which would multiply me to give me 0. Okay. So basically what I mean to say here, if we have a factor x minus 2, and if we solve it for 0, we would get x equals to 2 as a factor. So again, if I were to repeat what I just said, is that the only way I would know that this gx is a factor of fx, sorry, x minus 2 is a factor of fx, is that the other side of fx would be equals to 0. And how do I reach that? That comes when x minus 2 or gx will be 0. Now, gx is already a function. They have defined this. So, x minus 2 is supposed to be equals to 0. So, x minus 2 will become 0 when x equals to positive 2. And that's when we input it. Now, again, if I input positive 2 into this equation, fx equals to 2 minus 2, which becomes 0 multiplied by gx. And if I get fx is equals to 0, then I would say what? I would say that this gx is a perfect divisible of fx. Okay. So basically what I mean by this is, now if I have x cubed minus 8, and if I input the values 2 into this equation, I would already know that this is perfectly being able to be divided by x minus 2. I hope that clarifies. It's an overcomplication, but basically, if I were to just put it in a simple terms, let me just take this up. I would define this as, if there's like fx is equals to something like x minus a multiplied by, for example, another function which I would call gx, then I would know that if I substitute x is equals to a into this equation, gx would become a, sorry, fx would become equals to 0, and that would mean that it is a factor. Okay, I hope that clarifies it. So basically, if I have fx is equals to 0, I would say that x minus a, the value x minus a would be a factor of fx. And why is that? Because the factor, if I input that value into this equation, I would get something equals to 0. And I'll get to this, and it will make sense uh, as we go throughout the lectures. But for example, if you do not have, if for example, if x minus a would not multiplied by gx would not have been perfectly divisible by something, I would never get fx is equals to 0. Okay, just remember, fx is equals to 0 only comes up when it is perfectly divisible by 0. So now, for example, I'll just give you a short example. For that, let me just take this up here, put it here, take this one and put it there. So now the example I'm going to tell you, this is one of the most important things you have to learn. Okay. Okay. Now, for example, I already have a question which is in the practice exercise. So basically, if I have, for example, something which is x is equals to 2, okay, they've told us that 4x cubed minus 8x squared minus x plus 2 is divisible by x minus 2. So basically, what this basically means is that if I divide x minus 2, 4x cubed minus 8x squared minus x plus 2 by x minus 2, I'll get a perfect answer, because this basically means that when if I say that 36 is divisible by 2, okay, that would mean that 36 and 2 would be divisible and it would give me 12 as the answer. But if I would say 36 is divisible by 7, this would be a wrong statement. Why? And that's because if I were to write this in this way, if I just divide it in front of you right now, 7 divided by 36 divided by 7, okay? And now the thing is, if I were to just say 7 fours is 28, so in fact 7 5 is 35, 7 5 is 35, and I subtract this, I would get positive 1. And now there's nothing I can do except add a point. So if I were to say, if I were to leave it here, I would say that we have a remainder of 1. And when anything is divisible by any other thing, it never leaves up a remainder. So for the same example, I would get 13 divided by 2 if I would take it here. 36 divided by 2, sorry. 2 and 36. So I already know, by the way, that it's 18, but even if I were to break it apart, okay, I would take 2 ones as 2, and then I would cancel this out, I would get 1, and then I would take 6 here, then I would say 2 8 to 16, then 16, and then cancel it out. So basically, the end of the day, I get 18 as the answer. And when do I get the answer? When it is perfectly divisible and it has 0 as the remainder. So whenever something has a remainder of 0 if being divided, then we say it is divisible by that value. Okay, I hope that clarifies it. So basically, when I get 4x cubed minus 8x squared plus 2 minus x plus 2 is divisible by x minus 2, I would say that at the end of the day, I do not have any remainder. Okay, so I do not have any remainder. And the factor theorem actually states that if I were to put this factor or which is being divisible, which the equation is originally divisible by, I would just say that x minus 2 should be equal to 0. It is a factor, so that's why it's going to be x plus 2. Now, if I were to input the value of x into 4x cubed minus 8x squared minus x plus 2 into, if I were to input my value of 2 into this equation, I would get 0. And why is that? Because I already know it is divisible by x minus 2. If this was not divisible by x minus 2, then my answer would be never equals to 0. So now let's just test it up. For example, this is 4 multiplied by 2 cubed minus 8 multiplied by 2 squared minus 2 plus 2. So minus 2 and plus 2 cancels out. 2 cubed is equals to 8. 8 fours is 32. And 32 minus 32 is equals to 0. So 0 is equals to 0, and this is correct. So through this factor theorem, we can already prove that it is divisible by x minus 2 because it does not have any remainder, and the remainder is 0. So for example, if they were to say 4x cubed, and this is a concept which will come in the future while we do these lectures, minus x plus 2, this is called the remainder theorem, not the factor theorem. So if I would have something like 4x cubed minus 8x squared minus x plus 2, and I have x plus 3 here. Okay, so basically what that means, if I take the factors of x plus 3, I would find out that x plus 3 is equal to 0 and x is equal to negative 3. So when I have a negative 3 factor, now if I were to input the value of negative 3 into the equation, I would get the remainder of it. So basically, whatever our, what do we call it? Wait a second, let me just remember it. Whatever our divisor, in fact, whatever our divisor is, the divisor is, if we input the corresponding value of x into the original equation, which is the dividend, we'll get the remainder from that. Okay. So again, if I were to prove this, 4 multiplied by negative 3 cubed minus 8 multiplied by negative 3 squared minus negative 3 plus 2, simplify this, 3 cubed inside a negative is going to give us negative 27. So negative 27 multiplied by 4 is 108. So negative 108 minus Minus 8 multiplied by positive 9 would become 8 multiplied by 9 is 72. Negative 72 plus 3 plus 2 is equals to 0. Well, it's not technically equals to 0. In fact, just find out the value right now. So negative 108 minus 72, negative 108 minus 72 plus 3 plus 2 is going to give me negative 175. Okay, so I can confidently say that negative 175 will be the remainder if I divide this value by what? Negative x plus 3. So this is the remainder theorem. It's right now not in this exercise, but it will come in the next exercise. So just remember one rule, and that's we take the factor, we are dividing any equation by, we find out the x values, we input that x value into our equation, and we get what we call the remainder of our answer. And when our remainder is equals to 0, we can say that our equation is perfectly divisible. For example, we have this one. We can perfectly say that this equation is divisible by x minus 2. And what would I give the reason this for? Because if I input x is equals to positive 2 into this equation, I'll get a remainder of 0. And whenever we get a remainder of 0, what do we say? We say that it's going to be perfectly divisible, and that's it. So that was basically what this exercise was about. Now we'll go into the practice questions. I hope everything is clear. If it is not, feel free to ask in the comments and I'll try my best to answer your queries. So we'll go into the practical stuff now. So use the factor theorem to show this, and I'll just go up and explain everything step by step. So these are really basic questions. Like we won't spend much time on this. Let me just make some margins there. Okay. Now that we have this, we say question number 1, part A. They've already showed, they've told us use the factor theorem to show. We have to show them, we have to prove them. We do not have to do like solve this up for this or something. We just have to show that x minus 4 is a factor of x cubed minus 3x squared minus 6x plus 8. So they've told us already that x minus 4 is a factor. Now we have to prove them through the factor theorem. So what does the factor theorem state? Find the value of x, which is x minus 4. If I were to input that equals to 0. Again, why is that? Because if I have a function fx, let's assume this fx is equals to, wait a second. This fx is equals to x cubed minus 3x squared plus minus 6x plus 8. So fx would actually be equals to 0 only when what? The factor x minus 4 is equals to 0. Okay, so whatever, for example, we have something like ax squared plus bx, which gives multiplied by x minus 4 would give us x cubed minus 3x squared plus minus 6x plus 8. Okay, you already know this. So when would this become 0? When would the remainder become 0? And that's only possible when we say that the factor is equal to 0, and thus we do this x minus 4 is equal to 0. Okay. Okay. Now, what I'm going to do next is I'm going to solve for this. So again, I know x minus 4 is equal to 0, so x is equal to 4. Now, input this value of x equals to 4. And if the answer comes as 0, we can say that this is a factor, hence proved. Okay. So 4 cubed minus 3 multiplied by 4 squared minus 6 multiplied by 4 plus 8. Now again, what is 4 cubed equals to? 4 multiplied by 4 multiplied by 4. We have got 64. And then we have 4 4 is 16. 16 multiplied by 3 is equals to 48. 64 minus 48 minus 6 4 is 24 plus 8. Now negative 48 minus 24, negative 48 minus 24 plus 8 plus 64 is going to be equal to 0. So 0 is equal to the remainder, or you can say, we will just say, hence proved that this is a factor. So this is basically what you have to do. There's no rocket science to this. I hope that clarifies the concept. We'll go through the next questions a bit quickly. So we have got, wait a second. So we have got x plus 1 is a factor of x cubed minus 3x minus 2. So what I'm going to do now is, again, I will just assume x plus 1 is equal to 0. So x is equal to negative 1. Okay. So when x equals to negative 1, I'll input this into the equation negative 1 cube minus 3 multiplied by negative 1 minus 2. So negative 1 cube is negative 1, positive 3, and minus 2. So what is 3 minus 2? It's going to be equal to 1. Negative 1 minus 1 is equal to 0. And we can again say this is hence proof. Now, any other value except 0 would be incorrect. Okay, now for part C, we have x minus 2 is a factor of 5x cubed minus 7x squared plus 28. Okay, now that we've got this, what I'm going to do is I'm going to say x minus 2 is equal to 0, x is equal to positive 2. Now again, I'm going to input this value 5 multiplied by 2 cubed minus 17 multiplied by 2 squared plus 28. Okay, now I'm going to say 2 cube is equal to 8, obviously multiplied by 5 is going to give us 40, minus 17 multiplied by 4 is equal to 68 plus 28. Okay, so 68 plus 28 is equal to 96. Wait a second, I'm just 68, sorry, negative 68. Yes, negative 68 plus 28 is equal to negative 40, and 40 minus 40 is equal to 0, and hence proved that this is a perfect factor. Okay, again, I'm repeating, the only reason why we are getting this as a perfect factor is because we know it's directly divisible. And how do we know anything is directly divisible? It's when the remainder is equals to 0. And again, in the same case, it's equals to 0. So for part 1, D, we have 3x plus 1 is a factor of 6x cubed plus 11x squared minus 3x plus minus 2. So now I'm going to do, again, assume 3x plus 1 is equal to 0, as we have to find the corresponding value for that. And then again, we solve for the value of x, which is x equals to negative 1 over 3. Okay. Now in the next step, again, we are going to input the value negative 1 over 3 inside this equation. 6 multiplied by negative 1 over 3 cube plus 11 multiplied by negative 1 over 3 whole squared minus 3 multiplied by 1 over 3 and minus 2. So if I were to simplify this and this cancels down, 3 squared is negative 11 over 9, and this becomes, what is 3 cubed? Well, it's equal to 27. 6 divided by 27 would give me 2 over 9. So this would become negative 2 over 9 plus, in fact, plus 11 over 9, and this would become minus 2. So negative 2 plus 11 is equals to negative, what? Negative 2 plus 11. Why is that coming up here? Negative 2 plus 11 is basically equals to 9. Well, and positive 9 over 9 minus 2. In fact, I'm really sorry, I just forgot adding this negative 1 here. The negative 1 inside this part. I just canceled this down and I forgot to add this negative 1. Negative 1 also come up here. Okay. Now that I have negative 1, I just say 1 minus 1 minus 2. So 1 minus 1 is going to be becoming, wait a second, I think I've made a mistake up here. 6 multiplied by negative 1 over 3 cube is going to give me negative 2 over 9. And then positive 11 over 9 minus 1 minus 2. I think this, oh, it's negative 1 over 9, so it's become positive 1. This was negative 1 over 3. I copied the factor wrong. I'm really sorry for this mistake. This would be positive 1 and this would be positive 1 also. So 1 plus 1 is 2. 2 minus 2 is equals to 0. And again, hence proved that this is effective. Uh, okay, for question number 2, part A. Now, again, find the value of A in each of the following. X plus 1 is a factor of 6x cubed plus 27x squared plus ax plus 8. Now, what they've told us is that they've already told us, don't prove us. They've told us just, you should know already by now. Well, they have not told us you should know. They've told us, I'm telling you that x plus 1 is a factor of this thing. So we know that 6x cubed plus 27x squared plus ax plus 8. We know that when this is divided by x plus 1, the remainder of that division, whatever it is, it goes on and on and on. And this remainder of the division is 0. So it's perfectly divisible by x plus 1. So basically, if I were to say that if I have the value for x plus 1, I would say x plus 1 is equal to 0, and I've got x is equal to negative 1. So now if I were to say 6 multiplied by negative 1 cube plus 27x squared, which is negative 1x squared, plus a negative 1 multiplied by a plus 8. Okay. So now that I have this, I would say if I input this value of negative 1, my answer should be equal to 0. And why is that? Basically, because I've already told you that if I were to divide these things up, I would get a factor, I would get a remainder of 0, which would mean this is perfectly divisible. So if they're telling me this is perfectly divisible by this, they're already telling me the remainder of this division would become 0. So the remainder of the equation would become 0, and thus we have substituted it into this equation. Again, we discussed earlier, if we take the value of x for the factor, input that value into the original equation, we get what we call the remainder of the division. Now that we already know this, this is a factor, so we know the division is the remainder is going to be 0, and thus we have written it this there. I don't know why I'm over explaining this basically, but it's just a simple concept, and you practice it, you get to know about this. But just clarify, if your concept is clear, you can solve any question that comes in front of you. So first things first, try clearing your concept. If you do not understand it, now just go up, repeat this video, go back, and come back again. Try to solve some questions, and soon you'll get the hang of it. So it's nothing illogical, by the way. It's AddMaths and math. These are some subjects which are going to benefit you in one way or another. I mean, they're always logical. They are always going to prove you're doing something because of this. Okay. So I don't know. Many people love chemistry. I don't like chemistry personally. It's obviously it's personal choice, but chemistry is something I personally don't ever like because sometimes it's logical, sometimes it's not. I don't know. So that's why I don't actually like chemistry. But yeah, maths is fun. It's always giving you reasons for every single thing, so you know the logic behind it. So again, negative 1 cube is going to give us 6 multiplied by negative 1 plus minus 27 squared. So this is going to be plus 27. And minus a plus 8 is equals to 0. Now what I'm going to do is solve this for the value. Negative 6 plus 27 plus 8. Negative 6 plus 27 plus 8 is going to give me 29. So 29 minus a is equal to 0. And then we have negative a is equals to negative 29, and a is equals to positive 29. So we have got the value of a. Just give me a second before I could open the answer just to double check if I've done everything correct or not. Just give me 1 second. Okay. Now for Chap exercise 3.2, we are on question number 2. And let me see 3x squared plus 2x. I have 2a. Yes, 2a is equal to 29. And my bad, by the way, from the start of this exercise, I'm sorry, my screen went blank. From the start of this exercise, I've been saying exercise 3.2, while in actual, this is exercise 3.3. So my bad for that. But a is equal to 29. Now proceeding on for b. So they've told us already x plus 7 is a factor of this part. So again, we take the x plus 7. We know that x plus 7 is equals to 0. So x equals to negative 7. Now that we have a value, they've told us it's a factor. So factors have a remainder of 0. So if I were to input negative 7 cubed minus 5 multiplied by 7 squared minus 6x plus a, I should get a remainder of 0 as this is a factor. So 7 cube is actually equals to what? 7 cube is 343. I never knew this. So 343 is 7 cube minus 7 7 is 49. 49 multiplied by 5 is 245. Negative 245 minus 6x plus a is equals to 0. So 343 minus 245 is going to give me 98. So 98 minus, in fact, I did not input 6x. So minus 6 multiplied by negative 7 plus a is equals to 0. 98 plus 7, 6 is 42 plus a is equals to 0. So a is equals to 98 plus 42 and negative 40. So it's a is supposedly equals to negative 40. And let me just check. This is wrong. Cut. No. Okay, for part B, again, the same thing. X plus 7 is a factor of x cubed minus 5x squared plus minus 6x plus a. So again, x is equals to negative 7 is supposed to be the value for x, which would give the remainder 0, because the remainder 0 is coming because of the fact that it's a factor. X plus 7 is a factor of this value. So we would get a remainder of 0. So if I were to input this negative 7 cubed minus 5 multiplied by 7 squared minus 6 multiplied by negative 7 plus a. So this should be equals to 0. Negative 7 cube is equals to what? 343. So this would be negative 343 minus 7 squared is 49 multiplied by 5 is going to be giving me 245. So minus 245 plus 7 6 is 42 plus a should be equals to 0. So a is actually equal to negative 343 minus 245 plus 42. So this would be equals to negative 546, and negative 546 on the other side would become positive 546. And that's it. This is your answer for part B. Okay, for part C, we have 2x plus 3 as a factor. Now again, 2x plus 3 is equal to 0, x is equal to negative 3 over 2, because this negative 3 comes up here and then divided by 2. Now we have the factor. They've already told us that 2x plus 3 is a factor. So the remainder of this should be equal to 0. So we add this into the equation, negative 3 over 2 cubed plus a multiplied by negative 3 over 2 whole squared plus 29 multiplied by negative 3 over 2 plus 30, and that should be equals to 0. As they've told us, it's a factor in the question. Now negative 3 over 2, and we put this in a whole cube, we get something like, let me just see. Okay, so we get negative 27 over 8. This was just rechecking. And if I would multiply negative 27 over 8 by 4, I would get negative 27 over 2 plus negative 3 squared is equal to positive 9a divided by 4 plus, in fact, minus 29 multiplied by 3 is going to give me 87 minus 87 over 2 plus 30 is equal to 0. Now that I have negative 87 minus 27 divided by 2 is going to give us negative 57. Negative 57 plus 30 is going to give us negative 27. So negative 27 plus 9a divided by 4 is equals to 0. So 9a is equals to positive 27 multiplied by 4. Basically, because 27 coming here become positive 27, and then this 4 multiplied by 27. So 9a is actually equals to 27 multiplied by 4 is 108, and a is equals to 108 divided by 9, which is equals to 12. And that is your answer for question number 2, part C. I hope that clarifies it. Proceeding on to question number 3. So they've already told us again here that x minus 3 is a factor of x cubed plus ax squared plus bx minus 4. So they have told us to express b in terms of a. Now, there's no big deal in this. Just they've told us to give the answer in terms of an unknown. So basically, we first have to find the value of b. And how do we do that? They've already told us that x minus 2 is a factor. Okay, so when x minus 2 is a factor, it's... Wait a second. I don't know why this is glitching or something. So they've told us x minus 2 is a factor. And when x minus 2 is a factor, that means x is minus 2. Wait a second. X minus 2 is equal to 0 and x is equal to positive 2. So they've told us if I were to input x equals to positive 2 into this equation, I should get the answer as equals to 0, because when something is a factor of something, the remainder is equals to what? It's equals to 0. So I'm going to apply the same thing here. X cubed, which is going to become positive 2 cubed, plus a multiplied by 2 squared plus b multiplied by positive 2 minus 4 is equals to what? 0, because it's a factor. Now again, I simplify this. 8 plus 4a plus 2b minus 4 is equals to 0. Now what have they told us to find out? B. In which terms? They have told us to find it in terms of a. So first of all, find the value of b. 2b is equal to what is 8 minus 4? It's equal to 4. This on the other side would become negative 4. Negative 4a. Negative 4 minus 4a is equal to 2b. b is equal to negative 4 minus 4a divided by 2. And b is equal to 2 on the 2, 2 to the 4, 2 to the 4. So b is equal to negative 2 minus 2a. And that's your answer, as we have expressed b in terms of a in this question. Okay. b minus 2a. Yes, it's done. So for question number 4, find the value of a and the value of b. Wait a second. Okay. For question number 4, part A, we have x squared plus 3x minus 10. X squared plus 3x minus 10 is a factor of x cubed plus ax squared plus bx plus 30. Okay. Now, the thing is, we have got two unknowns and we have to find two factors of it. And we already have found out that whenever something is a factor of anything, we say that the answer would be equal to 0, and we'll get to it again. Let me just first solve this equation. For example, if I were to expand this x squared plus 3x minus 10 to find out the actual factors, the values of x for which they would be a factor, I would first equate this equals to 0. Then I would say x squared plus 3x minus 10. So then what would be factors of 10? 5 and 2. So x squared plus 5x minus 2x minus 10 is equals to 0. and then x as the common, x plus 5 here, minus 2 as the common, x plus 5 here is equal to 0. So we have got x plus 5 multiplied by x minus 2 is equal to 0, which gives us x is either equal to negative 5 or it's equal to positive 2. So now we have got two factors for x. Next step I'm going to do is quickly first divide this up. Okay, the next step I'm going to do is I'm going to equate this equation. When you equate this equation, so now I'm going to do first when x is equal to negative 5. When x is equal to negative 5, I'm going to input negative 5 into this equation. This is going to give me negative 5 cubed plus a multiplied by negative 5 whole squared plus b multiplied by negative 5 plus 30. Now the next thing I'm going to do is equate this as equals to 0. So when something is a factor of anything else, we just say that it's going to be equals to 0, because if I input the value negative 5 into the equation x cubed plus ax squared plus bx plus 30 is going to be perfectly divisible by us. So that's why we're going to equate this as 0. Now again, negative 5 cubed is going to be equals to negative 125 plus 5 5 25 a plus, instead we're going to get negative 5b plus 30 is equals to 0. Okay, so if I were to simplify this equation, what is negative 125 plus 30 is going to become negative 95, and before that we've got 25a minus 5b minus 95 is equals to 0. Okay, so if I take 5 as the common, 5a here as the common, and 5a minus b minus 19 is equal to 0. And then again, this 5 goes on the other side and practically becomes equal to 0. So that's not a big deal. Now we have got negative b 5a. In fact, 5a minus b minus 19 is equal to 0. If I were to do it in a more simple form, 5a minus 19 is equal to positive b. And now we have this one equation. Now for equation 2, we input the second value of x when x is equal to positive 2. And now again, for this value, it's x cubed plus ax squared. In fact, I'll just write this as this 2 cubed plus a multiplied by 2 squared plus b multiplied by 2 plus 30. All of this is going to be equal to 0. And now I just simplify this equation. What's 2 cubed? It's 8, obviously. So 8 plus 2 squared is equal to 4. 4 multiplied by 9 is equal to 36. Plus 6 to the 12 plus 30 is equal to 0. Sorry, oops, my bad. I thought this A is 9. My handwriting is bad, sorry for that. So 2 to the 4, so 4A plus 2B plus 30 is equal to 0. And now simplify this equation. In fact, you could just really quickly simplify this. 4A plus 2B plus 38 is equal to 0. And then you could term this as equation 2. And now you can just simply say per equation 1 into equation 2. And now what I'm going to do is just utilize my value of b in the first equation. So I've got 4a plus 2 multiplied by 5a minus 19 plus 38 is equal to 0. And now this is going to give us 4a plus 5 to the 10a minus 19 multiplied by 2 is going to give me, let me just check, 19 multiplied by 2 is 38 minus 38 plus 38 is equal to 0. So this cancels down. We've got 4a plus 10 is equal to 0. So this is going to be 14a is equal to 0. And then we get a is actually equal to 0. For the value of b, we get 5a minus 19 is equal to b. So this is going to be negative 19 is equal to b. So these are the two values we have got for this exercise. And let me just double check if this is correct or not. Okay, for part B, we have 2x squared minus 11x plus 5. And we have to prove that this is a factor of x cubed minus 17x squared plus bx minus 15. Now, we do know that this is a factor, and first steps first, we have to find out the values of x for this quadratic equation. So 2x squared minus 11x plus 5, I can just simply just take this. A is equals to 2, B is equals to negative 11, and C is equals to positive 5. And minus B is positive 11, plus minus under root B squared is going to give me 11 squared, negative 11 squared. So what's negative 11 whole squared? It's 121 minus 4 multiplied by A, which is 2, multiplied by 5, and divided by 2 multiplied by 2. Simplify this, we get 11 plus minus under root 121 minus 4 2 is 8, 8 5s is 40, and 121 minus 40 is going to give us minus 40 is going to give us 81. Under root 81, as we all know, is 9. So divide by 4. So we have two values for x: 11 plus 9 divided by 4, or 11 minus 9 divided by 4. So x is either equals to what's 11 plus 9? It's equals to 20, and 20 divided by 4 is equals to 5. So x is either equals to 5, or x is equals to, what is 11 minus 9? It's 2. 2 divided by 4 is going to give us 1 over 2, and or x equals to 1 over 2. So now we have two values for x in this equation. And what that basically tells us that x cubed minus 17x squared plus bx plus minus 15, sorry. This is going to be perfectly divisible by the values x equals to 5 or x equals to 1 over 2. So that means if we use the factor theorem or the remainder theorem, in fact, we could say that for the value of 5 or 1 over 2, this whole equation x cubed minus 17x squared plus bx minus 15, which should be equals to 0. So that's what I'm going to plug in. A multiplied by 5 cubed minus 17 multiplied by 5 squared plus b multiplied by 5 and minus 15. So this should be equals to 0 when this value of 5 is input here. So what's 5 cube? Well, 5 cube is 125. We all know that. Multiplied by a is 125a minus 5 5 is 25. 25 multiplied by 17 is going to give us 425. So minus 425 plus 5b minus 15 is equals to 0. If I want to simplify this, I would get 125a plus 5b equals to what is negative 425 minus 15. So 425 plus 15 is going to give us 440. So this is going to become positive 440 on the other side. And then we can simplify this. Take 5 as the common here. So 125 divided by 5 is 25. 25a plus b is equals to 440 divided by 5 is going to give us, let me just check, 88. And we've got b is equals to 88 minus 25a. So this is going to be equation number 1 for this question. For equation number 2, now we have to find the value of a. For this, again, we use the value 1 over 2 and input this into our equation x cubed minus 17x squared plus bx minus 15 and equate that equal to 0, because this would perfectly factorize that value. So if I were to input this, a multiplied by 1 over 2 cube minus 17 multiplied by 1 over 2 squared plus b multiplied by 1 over 2 minus 15 is equal to 0. Now that we have got these values, I'm going to use 1 over 2 cube is obviously 1 over 8 I would say. But before that, let me just do it. Okay, 1 over 8a minus 1 over 2 is, whole square is equal to 1 over 4. 1 over 4 multiplied by 17 is again going to be equals to 17 over 4. So minus 17 over 4 plus 1 over 2b. I just do it this way. 1 over 2b minus 15 is equals to 0. If I were to simplify this, 842. Okay, so 1 over 1a minus 17 multiplied by 2. I'm going to take the LCM, by the way. So 17 multiplied by 2 is going to be 34, and plus 2 multiplied by 4 is going to give me 4b divided by 8 is equals to positive 15. Okay, now if I were to simplify this, a minus, in fact, a plus 4b is equals to 15 plus 15 multiplied by 8 is 120. 120 plus 34 is going to give us 154. Okay, so this is equal to 154. This is actually equation number 2. Now, if I were to use the value of b in equation number 1, which we have got around here, I could just simply find out the other value. So a plus 4 multiplied by 88 minus 25a is equals to 154. Now I've got this a plus 88 multiplied by 4 is equals to 352 minus 25 multiplied by 4 is going to give us 100. Okay, now that we've got this 100a, and that should be equals to 154. Now simplify this. We've got negative 99 plus 352. In fact, just remove the plus here. Is equal to 154 minus 354. 154 minus 352. Sorry. So this is going to give us negative 198. But this is a here. Negative cancels out. Negative a is equal to 198 divided by 99. That is going to give us positive 2. And that is the value of a. For b, we have b is equal to 88 minus 25 multiplied by a, which is obviously we just found out a is equal to 2. Let me just highlight that. Okay. So b is going to be equal to 88 minus 50, and b is 88 minus 50 is 38. So a is equal to 38. So that's it. This is it for part B, 38 and 2. So part C, let me just continue here. Part C, we have 4x squared minus 4x minus 15. Again, we know that this is a factor. So first we find out the values of x for this factor. So for that, we equate this equals to 0. 4x squared minus 4x minus 15 is equals to 0. Simplify this, we have got, let me see, a is equals to 4, b is equals to negative 4, and c is equals to negative 15. So minus b is positive 4 plus minus under root b squared is 4. 4 is 16 minus 4 multiplied by a, which is 4 multiplied by c, which is negative 15, divided by 2a, which is 4 multiplied by 2. Simplify this, we get 4 plus minus under root of what is 16 minus, so 4 4s is 16. 16 multiplied by 15 is going to give us 240. In fact, we've got positive 240. What is positive 240 plus 16? It's 256. I've got it here, divided by 4 2s are 8. So what is under root of 256? It's 16. So 4 plus minus, so we have got two values actually, 4 plus 16 divided by 8, or 4 minus 16 divided by 8. So the two values of x, you've got x is either equals to 16 plus 4, it's 20. 20 divided by 8 is going to give us 5 over 2, or x is equals to 4 minus 16. 4 minus 16, wait a second. 4 minus 16 and divided by 8. So this is going to be x equals to negative 3 over 2. Okay, so we have got these two values of x, and these two values basically mean that if we input these values in 4x cubed plus ax squared plus bx plus 30, we are supposedly going to get the 0 as the output. So again, I'm going to input these values: 4 multiplied by 5 over 2 square cube plus a multiplied by 5 over 2 squared plus b multiplied by 5 over 2 plus 30, and that should be equal to 0. Okay, now we've got this cube, so 125 divided by 8 multiplied by 4. 125 divided by 8 multiplied by 4 is going to give us 125 over 2 plus 25 divided by 4a plus 5 over 2b plus 30 is equal to 0. Okay, now that we have got these values, take out the LCM. We have got 125 multiplied by 2. In fact, 125 multiplied by 2 is 250. So 250 plus 25a plus 5 2 is 10b is equals to minus 30, and in the denominator we have got 4. So simplify this: 25a plus 10b is equal to what is negative 30 multiplied by 4. Wait a second. 30 multiplied by 4 is 120. So negative 120. And positive 250 goes on the other side to give us negative 250. Okay. So 25a. In fact, if I were to take 5 as a common. Okay. Let me take 5 as a common. 5 plus 2b is equals to what is negative 120 minus 250. Negative 120 minus 250 is going to give me negative 370. Negative 370 divided by 5 is going to give me negative 74. So 5a plus 2b is going to become equal to negative 74. So we have got this as equation number 1. For equation number 2, I'm going to raise this part. Yes. Let's do this. Okay. Okay, for equation number 2, we just input the other value, which is negative 3 over 2. So again, 4 multiplied by negative 3 over 2 whole square, whole cube, plus a multiplied by negative 3 over 2 whole squared plus b multiplied by negative 3 over 2 plus 30 is equal to 0. Okay, now that we have all these values required, we are going to solve this up. Okay, so negative 3 over 2 cube is going to give me negative 27. 4 multiplied by negative 47 divided by 8 plus a 9 divided by 4a plus in fact minus 3 over 2b is equal to negative 30. Now again, 4 1 is 4 is 4 2 is 8. Take out the LCM. Negative 27 multiplied by 2 is going to give me 54. So this is going to be negative 54 plus 9a minus 3 2 is 6b is equal to negative 30 multiplied by, in fact, just let me do each and every step clearly. So divide by 4. So this goes on the other side. We have got 9a minus 6b is equal to negative 30 multiplied by 4. What's 30 multiplied by 4? It's 120 again. So negative 120. And 54, negative 54 goes on the other side to give us positive 54. So negative 120 and negative 120 plus 54 is equal to negative 66. And 9a minus 6b is equal to negative 66. We can also take 3 as a common. So if we were to take 3 as a common, 3a minus 2b is equal to negative 66. and we've got 3a minus 2b. 66 divided by 3 is negative 33, I guess. Negative 66 divided by 3. Sorry, negative 22. Very sorry for that. Now the next step, we have got this 2. Now what we're going to do is we are going to equate these equations. So for that, I'm going to simplify this one. 2b is equals to negative 74 plus, minus 5a. And in fact, if I were to remove that 2, it should divide by 2 here. So b is actually equals to negative 74 minus 5a divided by 2. So I'm going to input this value 3a minus 2 multiplied by negative 74 minus 5a divided by 2. Yes, divided by 2 is equals to negative 22. 2 cancels on 2. We have got 3a plus 74 because this negative multiplies by negative here, plus 5a is equals to negative 22. Okay. So for this, we are going to just simplify this. 8a is equals to negative 22 minus 74. Minus 74. So we've got negative 96. So negative 96 divided by 8 is equal to negative 12. So a is equal to negative 12. What the value of a? For the value of b, we have, what is b equals to? B is equal to negative 74 minus 5 multiplied by a. Where what is a? It's negative 12 divided by 2. Okay. Simplify this. This is equals to 5 multiplied by 12 is 60. And positive 60, negative 74 plus 60 divided by 2. So b is actually equal to negative 74. What is negative 74 plus 60 divided by 2? It's negative 7. So we have got these two values of a and b. A is equal to negative 12 and b is equal to negative 7. And that's it for question number 4. Now proceeding on to question number 5. This is let's load up. Okay. It is given that x squared minus 5x plus 6 and x cubed minus 6x squared plus 11x plus a have a common factor. Find the possible values of a. Okay, for question number 5, the told us x squared minus 5x plus 6 and x cubed minus 6x squared plus 11x plus a have a common factor. And basically what that means is that first we have to factorize x squared minus 5x plus 6. And the factors we get from this equation would be the factors of this cubic equation. Okay, before we proceed, let me just get it straight up. Okay. Okay, now for question number 5. This is two. Just good enough. Question number 5. So first of all, obviously we are going to factorize x squared minus 5x plus 6. And that's basically what we are doing from the rest of the exercise. Minus 5x plus 6. You can solve this from the calculator if you want. I am using the midterm breakdown here. So this would be x squared minus 2x minus 3x plus 6 equals 0. And then x as the common, x minus 2 here, minus 3 as the common, x minus 2 here is equal to 0. So we have two values for x. X is either equals to positive 3 or 2. So now what we have is that if x has the factor of x in x cubed minus 6x squared plus 11x plus a is either 3 or 2, we can say that if we input these two values for x, we are going to get 0. So I'm going to input when x is equals to 3. So when x equals to 3 cubed minus 6 multiplied by 3 squared plus 11 multiplied by 3 plus a is equals to 0. Okay, so now I'm going to simplify this. So this would be, again, what is 3 cubed? 3 cubed is 27 minus 3 squared is 9. 6 multiplied by 9 is 54 plus 33 plus a is equals to 0. If I simplify this, I would get a is equals to 27. This would be a is equals to negative 6. Okay, so now again for the next value, when x is equals to positive 2. So we've got one value for a, by the way, and that's a is equals to negative 6. Now for the second value, we input the second value again. So we have got x equals to 2 as the second value. We are going to input this 2 cubed minus 6 multiplied by 2 squared plus 11 multiplied by 2 plus a is equals to 0, as this is a factor. So 2 cubed is 8. 2 squared multiplied by 6 is 6 4 is 24. Plus 22 and plus a is equals to 0. So we would get again a is equals to negative 6. So as we can see here, we've got one common value of a. And so a is equals to negative 6 is our answer for this part. Let me just create a partition here. And let's just move on to question number 6. Okay. For question number 6, what we're going to do is x minus 2 is a common factor of 3x cubed minus a minus b in a bracket x minus a x cubed minus a plus b multiplied by x plus 30. So find the value of a and b. So they have already done the first thing for us, and they've told us that x is equals to 2 is a common factor for both of these cubic equations. Now, again, what we are going to do is we have two unknown values. So again, we have to do substitution. Without it, we can't do anything. So first of all, I'm going to input x is equals to 2 into the first equation. Input value, or in fact, I would say factor, into equation 1. Okay. So now we input the value of x. So 3 multiplied by 2 cube minus a minus b multiplied by 2 minus 8, and as this is a factor, we are going to get 0 as the output. So 8 3 is 24 minus 2a plus 2b, because this negative is coming here also, minus 8 is equal to 0. Simplify this. Negative 2a plus 2b plus 16 is equal to 0, because 24 minus 8 is 16. So we are going to get, if we take 2 out of the 2 as a common here, so a plus negative a plus b plus what is it, 8 is equal to 0. So this is our new equation, which we call equation 3. So now we input factor into the other equation given in the question in equation number 2. Let me just label this. This is equation number 2. This is equation number 1. Now that we have this, just input the factor again here. Same steps. 2 cube minus a plus b multiplied by 2 plus 30. Okay, so we have got this 8 minus 2a minus 2b, because it's negative again, it's multiplying here, plus 30 is equals to 0. Simplify this. Negative 2a minus 2b plus 38 is equals to 0. Now take 2 as the common again. Negative a minus b plus, what is 38 divided by 2? It's 19 is equals to 0. So this is equation number 4. Sorry. Okay, so now I'm going to substitute the equations up. We have got negative a minus b plus 19 and is equal to 0. And for the second one, we have negative a plus b plus 8 is equal to 0. Add them up to get one value. Negative a plus negative a is negative 2a. Negative b plus b is nothing. It would give us 0. Plus 19 plus 8 is 27. So, and that's equals to 0. So now that we have this equation, we can say negative 2a is equal to negative 27. This cancels down. A is equal to 27 over 2. Or we could say 27 over 2a is equal to 13.5 in decimal places. And for the other value, which is for part B, we have, sorry, not for part B, for the value of B, we have negative a plus b plus 8 is equal to 0. So negative a is negative 13.5 plus b plus 8 is equal to 0. So b is equal to what is 8 minus 13.5. That is equal to negative 5.5. And when that goes on the other side, this is going to be positive 5.5. And that is your answer for question number 6. Proceeding on to question number 7. X minus 3 and 2x minus 1 are factors of 2x cubed minus px squared minus 2qx plus q. So we find the values of p and q. Okay, nothing hard. So we have got two values for x. We have in fact two factors, which are x equals to 3 and 2x minus 1 would give us x is equals to positive 1 over 2 as the factor, which means if we put these factors into the equation, into this cubic equation, we'll get the value equals to 0. So now again, I'm going to use this up. We use when x is equals to 3, I'm going to see the value of the equation. So we have got 2 multiplied by 3 cube minus p multiplied by 2 squared minus 2q multiplied by 3, sorry, not 3, 2 squared, 3 squared, plus q. Okay, this would give us 3 cube is what is 3 cube? 27. 27 multiplied by 2 is 54. 54 minus 3 squared is 9p minus 6q plus q is equal to 0. Okay, now simplify this. We have got negative 9p minus 5 q plus 54 is equal to 0. And this is for equation 1. Now for the other one, when x is equals to positive 1 over 2. Now again, input the same values, 2 multiplied by 1 over 2 whole squared, sorry, whole cube, minus p multiplied by 1 over 2 squared minus 2q multiplied by 1 over 2 plus q. Okay. Now simplify this. 2 multiplied by 1 over 8 minus p over 4 minus 2 and 2 cancels down. This will give us q plus q is equal to 0. This cancels down. 2 ones are 2, 2 fours are 8. And then let's make a partition. I've got 1 over 4 minus p by 4 is equal to 0. Or I would say 1 minus p is equal to 0 because there's we take the LCM of 4, we get 4, and then on the other side multiplies and becomes 0. So 1 minus p is equal to 0 and p is equal to positive 1. So now input value of p into equation number 1. So now that we have equation number 1, which is this, we have got negative 9 multiplied by 1 minus 5 multiplied by what is the value of q. We do not play. 5q plus 54 is equal to 0. So negative 9 minus 5q plus 54 is equal to 0. We just pretty print here. And then 54 minus 9. 54 minus 9 is 45. So negative 5q is going to be equal to negative 45, and this cancels down. Q is equal to 45 over 5. 4 is 45 divided by 5, and that's equal to 9. So Q is equal to 9 is the answer for the first part. Now that we've got this, we can just pretty print it in P is equal to 1, and then just take this as a final answer. Before we go forward, let me just make this a little bit more compact. Didn't realize. Okay, just leave it. Yeah. Okay. For part B, let me make some space. Okay, for part B, explain why x plus 3 is also a factor of this of the expression. Now the thing is, we already have two factors, and we can just simply, obviously we know this 2x cubed minus px squared minus 2qx plus q. In fact, in simpler terms, this would be 2x cubed minus px squared. The value of p is 1x squared minus 2qx would give us negative 18x plus 9. So this is a cubic equation. And when we talk about cubic equations, we do know that they are going to give us three factors. And in the question, we are only given two factors. Now, the thing is, they just told us to just prove and explain why x plus 3 is also a factor. Well, the first thing is, again, because this is a cubic expression, we are going to get a value for it. And the third thing, we are just going to solve it and explain it to them. Why is it? Because when we input x is equals to positive 3, we get x equals to negative 3 as a factor. Now, the thing is, if I were to put this value of x equals to negative 3 into the equation 2x cubed, right? So if I were to put negative 3 into 2x cubed minus x squared minus 18x plus 9, that if that value gives me 0, that means that it is perfectly divisible, or in other terms, x is a factor. For example, again, I've explained this many times, but for example, we have 4. So we have 2, and we divide 4 by 2, we get 2 to the 4. So minus this, and we get 0 as remainder. And the only time we get 0 as remainder is when we have a factor of 2, which is 2. I know this might sound confusing, but the thing is, when we input this value x equals to negative 3 into this, if this would be a factor, the answer would be 0. So we are going to just try that out. 2 multiplied by negative 3 cubed minus negative 3 squared minus 18 multiplied by negative 3 plus 9. So we have got negative 3 cubed is 27, negative 27, in fact, negative 27 multiplied by 2 is negative 54. Minus 9 minus 18 multiplied by negative 3 would give us positive 54 plus 9. So this negative 54, positive 54 cancels down, negative 9, positive 9 cancels down. So this 0 proves that x is equals to negative 3, or you could say x plus 3 is a factor. And that's it. This is your answer for question number 7, part B. Proceeding on to question number 8. Okay. For question number 8, they've told us x plus a is a factor of x cubed plus 8x squared plus 4ax minus 3a. Show that a cubed minus 4a squared plus 3a is equals to 0. X is equals to negative a is a factor, because that's what they've told us in the question. Okay, because x plus a is equal to 0, and then x equals to negative a. So we do know from the question that x equals to negative a is a factor. Now, if I were to impart it, they've just told us a cubed minus 4a squared plus 3a is equal to this 0. We have just supposed to show that. Okay, we just nothing explanatory. Just show that. Okay, and that's the first step. We know the factor, just input the factor into the cubic equation. So we have got negative a cubed plus 8 multiplied by negative a squared plus 4 multiplied by a, yes, multiplied by negative a. So this is supposed to be 0. Why? That's because x equals to negative a is a factor, and when we input a factor into the equation, it gives the output what? 0. So negative a cube would give us negative a cube, okay, plus a squared would become positive, so this would be 8a squared plus what would this give us? This would give us 4a squared. In fact, negative 4a squared is equals to 0. Okay. Oops, I forgot the negative 3. I just saw it right now. Let me just make some adjustment here. And this is going to be also a negative 3. I'm sorry, I copied the wrong equation. So now if I were to just simplify this, I would get negative a cubed plus 8a squared. In fact, this would be plus 4a squared minus 3a is equal to 0. Now you might say that the value here is not the same as the value here. Well, I would say that is because the only difference is the sign difference. And if you can see, we have a pattern that this is positive, this is negative. This is negative, this is positive, and this is positive, this is negative. So whenever we have an inverse relationship in signs, and on the other side, this is important, and on the other side, this is 0, then we shouldn't care about the signs. We can just inverse the signs. And that would be because we take negative as a common, a cubed plus, minus 4a squared plus 3a is equal to 0. So that would give, when this negative is here, it basically means negative 1. And when this negative 1 goes on the other side, it divides by 0 to give us nothing but 0. So a cubed minus 4a squared plus 3a would also be equals to 0. And that's the exact same equation as in the question. I hope that is clear. And that is hence true. Okay, now that we've got this, for part B, we are going to go for find the possible values of A. So now we have got the equation a cubed minus 4a squared plus 3a. Now we just simply have to find the possible equations. And how are we going to do that? So we first of all copy down the equation a cubed minus 4a squared plus 3a is equals to 0. Okay, now I'm going to do the middle term breakdown. Again, we can do this middle term breakdown in cubic equations also, or any other equation you want. But how are we going to do the middle term breakdown is we're going to break negative 4 in terms such that when we add it up, we get negative 4, but we multiply them to get positive 3. Again, the same thing in the middle term breakdown, which we did in square terms, okay, or quadratic equations. Okay, so now I'm going to take the factors of 3, which is obviously it's a prime number, so 3, 1, the 3 and 1. 3 and 1 would be the only factors. So now I'm going to break this down. A cubed minus 3a squared minus a squared plus 3a is equal to 0. Now again, as we did in the quadratic equations, we are going to do the same. A squared as the common, a minus 3. Take the first two terms, then we again take negative a as the common, a minus 3 equals to 0. So now again, a squared minus a is either equals to 0 or a minus 3 is equals to 0. So we have got two possible values, a squared minus a is equals to 0 here, or a is equals to a minus 3 is equals to 0. Now the first one is pretty straightforward, a is equals to 3. So we have got this, a is equals to a minus y equals to 0. And as you can see, in this subdivision, we got another two values of a. So that proves what? Because whenever we have a cubic equation, we are going to get three factors. The factors might be repeating, but end of the day, there's three factors. Okay, so a from this we deduce a is either equals to 0 or a is equals to positive 1 and a is equals to 3. So we have got three values of a in this in this question. A is equals to 0, 1 or positive 3, and that will be your answer for what question number 8. And that's it for today. I'll meet you in the next lecture. I hope you liked.